Right, I'm going to look at intermolecular forces. This is a question that commonly comes up in exams and a question that students can do really well at if they just remember a couple of things. Intermolecular forces, we're looking at bonding between molecules. So we're not looking at the bonding within a molecule, which as it's a molecule it's going to be covalent bonding. We're looking at bonding between different molecules. So as an example here, if you can see on the board, we've got methane, CH4. We've got a molecule of methane here and a molecule of methane there. The bonding between these atoms here is covalent bonding because it's two nonmetals. But what we're looking at here with intermolecular forces is the bonding between them. Okay, so intermolecular forces is the bonding between molecules. There are three types of intermolecular forces you need to know, and examiners love these and they love to ask these kind of questions in exams. They can come as a general question and they can also very much come up in organic section of chemistry that you'll study. Three types. You've got van der Waals forces here, or they're also called London forces. They've got other names as well. You've got permanent dipole-dipole, and you've got hydrogen bonding. Van der Waals forces occurs between all molecules. Doesn't matter what they are, molecules. All molecules will have van der Waals forces, and also atoms. So, for example, noble gases, the bonding between the intermolecular force between two atoms of a noble gas, for example, will be a van der Waals type. Permanent dipole-dipole, you need to have an atom which is more electronegative than another. And a beautiful example is hydrogen chloride, where you see here the chlorine, as you should know, is more electronegative than the hydrogen. Hydrogen bonding is a special type of permanent dipole-dipole, okay? It's a special type, and the criteria to have hydrogen bonding is having a hydrogen atom that is directly bonded to either a nitrogen atom, an oxygen atom, or a fluorine atom. If you don't have that criteria, you don't have hydrogen bonding. Okay, so we're still looking at intermolecular forces here. Three types now, remember this? We've got van der Waals, permanent dipole-dipole, and hydrogen bonding. Van der Waals is the weakest. It's also called temporary dipole-dipole because what happens is that as two atoms come together, the electrons form on one side or another of the atom. You can kind of see here, it kind of becomes like this. I'm not a very good artist, but I think you get the idea. You get these temporary dipoles, depending on you get this attraction and repulsion between the electrons present. But these are constant, and that forms the intermolecular force there. But this is constantly forming and breaking, switching like that the whole time, like that if you can imagine, and that's why these are so weak. Whereas with permanent dipole-dipole, and I said before, a great example is HCl. Great example to use. I'm trying to find my board over here. Here it is. I draw it up here again. Permanent dipole-dipole, there we go. You've got to have an atom which is more electronegative than the other. Chlorine is, lovely. And what happens, remember your definition of electronegativity, the relative attraction that an atom has for the bonding electron pair in that molecule, in that covalent bond. So the bonding pair will sit closer to the chlorine because it's more electronegative than the hydrogen, and you set up this little, here, this temporary charge here, like that. And that actually is permanent, that stays fixed, it doesn't move like these ones here. So that kind of intermolecular force that we have between two, like here, we've got these two coming together, there's your intermolecular bond there, that is going to be stronger than this one here. And again, hydrogen bonding, you need to have hydrogen bonded directly to nitrogen, oxygen or fluorine. Great examples, water, do you see here? The hydrogen is directly bonded to the oxygen. Hydrogen fluoride, hydrogen directly bonded to the fluorine. And here the ammonia, the hydrogen is directly bonded to the nitrogen. So in these cases here, what will happen if we use the water as an example, let's take this away here, what we end up seeing is in terms of, there we go, is that the hydrogen, the hydrogen bond will form here, you see? And it'll also form here, if you imagine another molecule of water coming up. So it's actually forming between the lone pairs of electrons on the oxygen atom. 3 types of intermolecular forces: van der Waals, permanent dipole, dipole and hydrogen bonding. Van der Waals is the weakest, hydrogen bonding is the strongest. But just remember one thing, that van der Waals occurs in all molecules. So a cunning question examiners will sometimes ask is they'll ask you for the strongest intermolecular forces present. Now in the case of water, it's always going to be hydrogen bonding, but it will also have van der Waals present too. Okay, so just remember that and make sure you read the question really carefully. That's intermolecular forces in a nutshell. Really easy and a really nice question to get good marks on.